Molecular geometry. In order to do the shapes of the molecule, you need to put the central atom in the middle, then surround the central atom with a given element. Before you do that, you need to figure out the valence electrons, and that is done by following the octet rule and looking on the periodic table. Remember that 2 electrons mean single bond, and 4 electrons mean double bond. 3D shapes. Bent means that there's 2 areas of electron density with 1 lone pair. There's linear, which has 2 areas of electron density, and trigonal planar, which has 3 areas of electron density. Then there's tetrahedral, which has 4 areas of electron density with 1 lone pair, and trigonal pyramidal, which has 4 areas of electron density with a lone pair. Critical thinking questions. What is electron region? It is the place around the central atom where electron can be found. Next question. What is the lone pair electron region? A place around the central atom where the electron is not bonding and another atom can be found. And what is the bonding electron region? A place around the central atom where the electron can also be shared. Fill in the blanks. The number of electron regions determine the bond angles, with this in mind, complete the following sentence. Any molecule that has a bond angle approximately 105 to 109 will have total electrons. Any molecule that has the angles approximately 120 will have a blank of total electrons. Any molecule with a bond angle with approximately 120 will have blank of total electron region. First blank is 4, next is 3, and the last one is 2. For this activity, you need to draw the given substance. So the first one is NO3 minus. As you can tell, it has a resonance structure, and it has a lone pair. And also is trigonal planar due to the lone pair. Next one is NF3. As you can tell, it has 1 lone pair, making it a trigonal pyramidal. CF4 is the next one. It is the standard tetrahedral shape. Which of the following SO2 or H2S is around 119? As you can tell by the structures, it is SO2 because 3 of electron pair domain, which corresponds to the bond angles near 120, as you can tell right here. Next is the Vesper theory. It stands for valence cell electron pair repulsion. Each pair repel each other, and so they want to get far away from each other as they possibly can. And a general rule is tetrahedral electrons are the farthest apart, with the angles being 109.5 degrees. What takes up more room, a lone pair of electrons or a bonding pair of electrons? A lone pair takes up more space, which means it squeezes a little bit closer, causing the smaller bond angle. It'll be more compact. For the following activity, fill in the arrows with the proper bond angle measurement. It could only be 109, 120, or 180. For the final activity, draw the given substance, NO3 minus. As you can tell, it has 3 resonance structures. Next, trigonal planar. Next is CH4. Basic structure, and it's tetrahedral. Next is HCN, and it has a triple bond, making it linear. Next is water. Water is bent, meaning there's 2 lone pairs. NF3 has a lone pair, making it trigonal pyramidal. And the last is SiO2 minus 2. And it's linear. Last question. Which is bent and has an angle of 109? Se2 or SeCl2? As you can tell, this has a ring effect, while the other is that shape. And it's SeCl2 that has the angle of 109.